Hello, welcome to episode 3, the 16, the homework 2 video. Yeah, this is for the problem 1. So problem 1 asks you to determine the total reluctance of this magnet structure. So for that, you at first you need to draw equivalent circuit. So there is the input source here, and as you can see here, so we have the reluctance here. So that means we have the magnetic flux source and one of the reluctance, another reluctance, and also have another reluctance. That is the reluctance 1, reluctance 2, reluctance 3. So what is the reluctance? Definition of the reluctance. The definition of reluctance is that the L1, right? L1 over mu, the magnetic permeability and area. So that means it should be 0.3 over 3000 times 4 pi times 10 to the minus 7, and you can use A1 here, 0.01, right? So this number should be 7.96 times 10 to the third. The unit is the one of the Henry or ampere turns per Weber. Okay, I put the unit here and relate to this one. So similarly, reluctance 2 is the L2 mu A2. That is the what? 0.1 over 3000 4 pi times 10 to the minus 7 and 0.0025. So that is the 10.67 times 10 to the third, this one. Likewise, the reluctance 3 is the L3 over mu A3. So that is the 0.3 over 3000 4 pi times 10 to the minus 7 and 0.01, and you get this value. So what is the total reluctance? For get the total reluctance, so you can get this equivalent circuit. This is reluctance 1. This is reluctance 2, 3. What is the reluctance 2, 3? Is that the 1 over reluctance 2, 3 is equals 1 over reluctance 2 plus 1 over reluctance 3. That means reluctance 2, 3 is reluctance 2, reluctance 3 over reluctance 2 plus reluctance 3. All right. So total reluctance is the reluctance 1 and reluctance 2, 3. That is the reluctance 1 plus reluctance 2, reluctance 3 over reluctance 2 plus reluctance 3 equal to 12.51 times 10 to the third. Okay, so yeah, this is the answer of the number 1A. So number 1B, so inductance, right? The definition of inductance is the N times the flux over current, right? So that is the same with the N times number of turn times current over current reluctance, right? Yeah, because that flux is the Ni over reluctance, right? So this means N squared over reluctance, total reluctance. So that is the 100 squared over 12.51 times 10 to the third. Yeah, that is 0.8 Henry. That is the answer of the B. Okay, now move on. The C. The C problem number 1C asks you what is the new value of the inductance if there is air gap here, right? So what that means? The air gap here, we have the air gap, the reluctance here, right? So the equivalent circuit looks like that. There is some flux source here. It's the same. Reluctance 1, reluctance 2. Here, reluctance 3, but this is the new reluctance gap, right? So reluctance gap is the air gap and mu 0 A. Here we assume that there is no flanging here, so A is equal to this area. So that means we have the 0.0001 air gap over 4 pi times 10 to the minus 7 and 0.1, right? Because the A3 here is the 100 centimeter square, so that is the 0.01 meter square, right? So this is the 7.96 times 10 to the third, this one, right? So here we assume that AG equal to, this is AG, and 3. So what is the total reluctance? Total reluctance is the R1 plus R2 times R3 plus R3 over R2 plus R3 plus RG, reluctance G, right? This is the 14, sorry, 3 times 10 to the third, right? So inductance is the n square over r reluctance, right? That is the 0.7 Henry. Okay, go ahead. The D asks you that as the gap is increased in size, length, what is the limiting value of inductance? So as the gap becomes longer, that means there is no flux. This is extreme case. So what that means, if the reluctance of the air gap goes increases, so there the flux can be flow. I cannot flow this way. So all of the flux follow this way. So because this reluctance is really high, so the flux cannot flow this way. So only you can consider only the reluctance 1 and reluctance 2. So total reluctance is just the reluctance 1 and reluctance 2. That is the 18.57 times 10 to the third, right? So this inductance is the n square over RT. So that is the 100 square over 18.57 times 10 to the third. That is equals to 0.54 Henry. This is answer for number D. Okay. That is the answer for problem 1. Thank you.